Hello geometry. So in this last video, I'm here to show you that any two reflections can be done as a single rotation. So another way to say that is a composition of reflections is a rotation. And so I'm going to model this here on a coordinate grid. That's not a straight line. Let's try that again. And so I'm going to go ahead and just give myself a coordinate grid. I'm going to plot down any series of points. I like this triangle right here. Actually, this triangle is the triangle that I really wanted. And ladies and gentlemen, we're going to reflect this triangle twice over the x-axis and y-axis and then show you that that's actually the same thing as just rotating this triangle 180 degrees. So first things first, reflecting this over the y-axis. So remember, the reflections really are just looking at that perpendicular distance and making sure it's equidistant on both sides. And so point B is 4 units away from the y-axis. And so that first reflection is going to be 4 units on the other side to get B prime. Same thing's going to be with C, except it's only 3 units away. And same thing with A, except it's 6 units away. There we go. Counted it correctly. And so one reflection down over the y-axis. Perfect. Let's do it again, this time over the x-axis. And so reflecting over the x-axis then, let's see here. Is there going to be a good color to match up with? Let's go ahead and keep with gray. Gray is a great color. So A is 2 units away from the x-axis, so 2 units away on the other side, keeping that perpendicular distance equidistant. We end up with A double prime. C is 3 units away, so 3 units away for C double prime. And then B is 1, 2, 3, 4, 5 units away, so we end up with B double prime. Ladies and gentlemen, by performing 2 reflections, we ended with C, A, B double prime. Now, let's go ahead and double check that this does actually work to be a rotation by 180 degrees. Let's model this with point A first. If this is actually truly a rotation, then I could count by points my 2 up, and then 1, 2, 3, 4, 5, 6 over. So I'm looking at A being -6, +2, which means it's 6 to the left and 2 up, and we can rotate that by 180 degrees. And so instead, my value of A double prime should be at, instead of 6 to the left, it should be 6 to the right. And instead of 2 up, it should be at 2 down. And guess what? 6, -2 is exactly where A double prime is. And so that's going to be true for all of the points. Where C was up 3, and over 3, it is now over 3 in the other direction, instead of going left, going right, and instead of up, going down. And then for B, we're going up 5 and over 4. And now for B double prime, we're going over 4 and down 5. And so it does indeed absolutely match up as a rotation, point by point, looking at how our directions are flip-flopped. And ladies and gentlemen, While I did model this looking at a x and y coordinate grid, going left, right, and then up, down, this is true for any series of reflections. No matter what angles the reflections are at, no matter where they occur, you will always be able to find a center of rotation and rotate from the very, very beginning to the very, very end. And so another way to say that is any composition of reflections does indeed make one single rotation. You can be as creative as you want, and it will always work. Ladies and gentlemen, thank you guys. I look forward to working with you this week. I look forward to seeing you guys on Wednesday and Thursday. We won't have meetings Monday or Tuesday, but I look forward to seeing you guys then. Take care. See you all soon.